Hey guys, it's Eddie the Magic Monk. In this tutorial, we're going to talk about why differentiating ln x gives you 1 over x. Now, I'm going to start by drawing a graph in GeoGebra and using this to explain it to you. So to start off, let's open up GeoGebra. Now, this is the classic version of GeoGebra. So let's type in y equals ln x. And you can see the graph of ln x looks like this. And let's just start off by explaining to you guys why the graph looks like that. Okay, let's start off with some key points. So I'm going to draw a point on this curve, and you can see that when x is equal to 1, y is equal to 0. So I'm going to write this down. So for y equals ln x, when x is 1, y is 0, let's look at some other points on this line. When y is equal to 1, x equals 2.72. Let's write that down. When x is equal to 2.72, y is equal to 1. And let's look at when y is equal to 2, what x equals. When y is equal to 2, x equals 7.39. So where do these numbers come from? Well, if you guys remember what ln means, ln basically means log base e of x. So log base e of x basically just means the exponential function, which is equal to 2.72 to the power of y is equal to x. So these numbers will match this equation. Okay, so that is the meaning of logs. The base to the power of the other side, so e to the power of y is equal to x. Now, since e is equal to 2.72, 2.72 to the power of y is equal to x. So the first number, this set of numbers just means that 2.72 to the power of 0 is equal to 1. 2.72 to the power of 1 is equal to 2.72. 2.72 to the power of 2 is 7.39, and so on. Okay, so now that we understand where this graph comes from, let's talk about how to differentiate this graph. Now, if you guys remember, if you differentiate an equation, it is the same thing as drawing a tangent line at where this point is and finding the gradient of the tangent line. So let's go ahead and draw a tangent line. Draw a tangent line at this point on this line, and you can see the gradient is always changing, right? The slope of the straight line is always changing depending on where you drag this line. So the next thing I'm going to do is I'm going to use the function in GeoGebra to differentiate. So I'm going to draw a new curve called the g function, and it's going to be the derivative of the f function, which is the ln x function. So I'm going to differentiate it and draw a new curve. So you can see I have y equals 1 over x is the black line, and it equals the derivative of the green line. So to show you why that is, I'm now going to draw another point on this black curve with the same x coordinate as point A. So in order to do that, I'm going to go draw a point, the x coordinate of point A, comma, and g of x of point A. Okay, so now I have another point called point B, and it always matches point A. Wherever I drag it to, point B will match its x coordinate. Okay, so the next thing I'm going to do is I'm going to compare the y value of point B to the gradient of my straight tangent line at point A. So I'm going to get my tangent line back onto point A. And here is the magic. Okay, you can see that the gradient of this black line, the gradient of the straight line, always matches the y coordinate of point B. So the gradient of the straight line right now is 0.35. And if you look at the y coordinate of this black line, it's also 0.35. Regardless of where you drag it. So this helps you to visualize that the black line is y equals 1 over x, and you can see that the y coordinate of 1 over x always gives you the gradient of the tangent line on the green line. Okay, hopefully this helps you guys understand a little bit about how to differentiate ln x. I'm going to put a link to this file in the description of the video. And another thing I want you guys to experiment is to open up this file up into GeoGebra, and I want you to start changing the original function y equals, I'm going to change it to something like 2 ln x, and watch how the derivative changes, and watch how the gradient of the tangent line, so this number here, 0.75, still matches the y coordinate of the black line, 0.75, 0.75. And you can also change what is inside the bracket of the ln function. So let's say I put in 3x. Okay, and you can see it still matches, and you can even put in 3x squared and it still matches. Okay, so the gradient of the tangent line always matches the y coordinate of the derivative. Just have a go at it. It's a fun way to discover how the derivative works. Thanks for watching, guys. See you next time.